So let's start 3.3, which is different type of statement. I mentioned this last time. I mentioned this last Thursday. In terms of a tautology, how can a statement be a tautology? If your final truth table, if you construct a truth table and your truth table make up all true value, every single last statement is a true value, then it's a tautology. And on the other side of the spectrum, how can a statement be a contradiction? Well, if your statement, if you construct your truth table and your truth table, the final step, the last result is all false, then it will be a self-contradiction. So those are the two extremes. The two extremes is you either have all true, tautology, or you have all false, then it's a self-contradiction. If you have a mixture, then we say neither a tautology, nor a contradiction. Okay. So in this sense, let's take a look at this item. You know, this is your typical item, your problem. They ask you determine whether the statement is a tautology, a contradiction, or neither. And in order for you to determine if it's a tautology, self-contradiction, or neither, you have to construct your truth table. Looking at this thing here, unless you memorize it, and hopefully not, you have a lot of things to memorize. Hopefully you don't memorize, looking at this thing, tautology, look at this thing, it's self-contradiction. Don't waste your effort in those. So how do we construct our truth table? So reminder, this is go back to 3.2. To construct the truth table, let's take a look at A. To construct any truth table for you guys, Alex give you the starter kit. Alex give you this starter kit, which is the P is true, true, false, false, and the Q is true, false, true, false, right? So how do we construct this truth table? Reminder, if we have a parenthesis, we need to start with the parenthesis first. So inside the parenthesis, we need to do this operation, and you ask yourself, what kind of operation do we have? What is the connector here? And hopefully you guys say that the connector that we have is the AND statement. And if you remember your AND criteria, if you don't remember your AND criteria, for me, my AND criteria is this: as long as I see a false, doesn't matter where, the two column I'm looking at, I look at the P, I'm looking at the Q. And this is my AND connector. As long as I see a false, the result will be false. That is how I remember my AND statement, my conjunction criteria. So my conjunction, my AND statement, as long as I see a false, between the two columns I'm looking at, as long as I see one false, the result is false. Doesn't matter where, as long as one of them false and both of them false, the AND statement will be false. Okay, so again, I don't see a false here, so that's true. Everywhere else is false. And so I'm done with the parenthesis. For me, because the next item is a conditional statement, an if and then statement, because it's a conditional statement for me, like I mentioned to you guys last time, this is the one and only time the order matter. Meaning whatever on the left, we need to look at first, and whatever on the right, we need to look at second. And this is the only reason, because the P is on the right, all I did was I take this P, whatever this P is, I take this P and I move it to the right. It's just easy for me. It's just easy for me to see, because all I'm doing is I take whatever this P is over here, true, true, false, false, it's the same P. Because like I mentioned last time, we only look at two columns at most. We only look at this two column, the two column we have, which is the parenthesis P and Q, imply P. And this is the one time that the order matter, which is the first thing that you need to look at, go over to the second thing. And reminder, the only time that is false, the conditional statement, the only time that is false is the first thing is true and the second thing is false. First T, second F. So we don't have that item, right? First T, second F, we don't see that. The first thing is true, second thing is true, this thing will be true. If the first thing is false, it will never be true, will never be false for a conditional statement. So if the first thing is false, it's automatically true. First thing is false, automatically true. First thing is false, automatically true. As you can see, this is your final product. And this is your final product, and your final product is all true. And since it's all true, everybody see that this is a tautology. And this is our objective in terms of how to determine, how do we determine if it's a tautology, a contradiction, or neither? Well, you have to construct the truth table. The easiest way is to construct the truth table. Okay, and when we get to 3.4, we see that the other item in terms of tautology, in terms of argument. But for now, question in terms of why this is a tautology and how can I derive from PQ all the way to this item here. Again, reminder, the and statement for me is as long as there's a false, the result is false. And let's take a look at this item here. And if you look at this item, we only have the and statement, right? P and Q, and not P and not Q. And I know it looks like it's massive. And when you do this thing here, you know, on Alex, do on your notebook, do on your scratch paper first, and then type your answer on Alex. Because if you do a lot on computer, your eye will trick you and you might make a mistake. So my advice is try to do on your piece of paper, try to do on scratch work, and then type your answer on Alex. Okay, so look at this item here. To do any truth table, Alex gives you this item PQ. And PQ is standard, it's the same, true, true, false, false, true, false, true, false. So we want to do this parenthesis first. And to do the parenthesis, this first parenthesis, P and Q. And just like before, P and Q for me, for the and, for the conjunction, as long as there's a false, the result is false. So we have true, false, 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 same as over here. So we finished this item, we finished the first parenthesis. Now we cannot do this item, we need to do the second parenthesis. In order for me to do the second parenthesis, do you agree that I'm missing a negation of P and I'm missing a negation of Q? So how do we do negation? Well, negation is easy because negation is the opposite. Whatever P is the opposite of P, which is false, false, true, true. And negation of Q is opposite of Q, which is false, true, false, true. So whatever Q is, that is my negation. Now I have the two items, I can work with this. And remember, for those of you who missed last time, remember, whatever the connector we have, in this case, this is my connector, whatever connector we have, we only look at two columns at most. So the two columns I'm looking at is my negation of P, negation of Q. And if I look at this two columns, do you agree that for my and statement, as long as I see a false, the result is false? So in this case, the first thing is false, the second one is false, the third one is false. I don't see the false at the fourth one, which is they are true. So given this item, this is what I have. I have the second parenthesis, I got it, ladies and gentlemen. Where's my second parenthesis? My second parenthesis is here. My first parenthesis is here after I erase this, right? So this is what I have in terms of my first parenthesis. My first parenthesis is this item. My second parenthesis is this item. So I got the two parentheses. Now I can finish the whole thing because now the only thing they ask me to do is compare the first parenthesis and the second parenthesis, which is my first parenthesis here. My second parenthesis is here. So how do I compare them? Which is my same thing goal. My connector is the and statement. My and statement tell me is as long as I see a false. As long as I see a false, doesn't matter where, I see a false here. So the first thing is false. I see a false here. The second thing is false. I see a false here. The third thing is false. I see a false here. The fourth thing is false. So as you can see, The first line, there's a false, so the result is false. Second line, there's a false. Third line, there's a false. The fourth line, there's a false. So everywhere is false. And if it's all false, if your final product is all false, then we say that this is a contradiction. You try to prove something. You try to prove your case, but somehow is all false, meaning you contradict yourself, okay? So if it's all false, and like I mentioned earlier, the two extreme, this is the two extreme. If it's all false, we say a contradiction. If it's all true, we say a tautology. So question of a tautology, everything you see is true. The contradiction, everything you see is false. Okay, the last final step, the last connector, or I should say the main connector. So question here in terms of a tautology or a contradiction. And lastly we have C. Right? And similarly to C, the first thing we need to do is we need to do inside a parenthesis, and inside your parenthesis, hopefully you guys see that this is your or statement, your disjunction. And for me, this is how I remember, as long as I see a true, doesn't matter where, as long as I see a true, in the first line I see a true, the result is true. The second line, I see a true, the result is true. And the third line, I see a true, the result is true. So that's what we have. I have true, true, true. I don't see the true on the fourth line, so that's why it's false. You know, if you want to remember the books, it's up to you. The books say the only time the disjunction is false is when both of them are false. For me, as long as I see a true for the or statement, as long as I see a true, the result is true. For the and, as long as I see a false, the result is false. So I have the first item. I have the first item, which is the parenthesis. Again, is not the whole item. It's not the whole item. In order to be a tautology or a contradiction, you only look at the last final statement. Again, none of this thing matter. Your goal is this. Your goal is you want to construct this item. Your goal is you want to construct this truth table. Where is that truth table? Where is that whole item? None of this thing matter. All of this thing is, imagine all of those items is your steps, right? You need the first step to get to the second step to get to the third to get to the fourth to get to the final step. And this is the final step. The final step, we have P and Q imply P. And that's what we have here, P and Q imply P. So you see that this is the statement we try to looking for. And if this is the statement we're looking for and the result here is we're looking for, we don't look at the whole truth table. The truth table as a whole is not important. It's the statement that we're looking for, right? So same idea go here, right? This whole truth table, each of the column is your individual step, right? Because you don't have it, you create the column. And this is your goal. Your goal is you want to have a column, just include this item. And that is where I have. Again, someone asked a question, how do you determine if it's a tautology or how do you determine if it's a contradiction? And that's why I stopped in terms of C. To determine if it's a contradiction or a tautology, you look at your last final result. If your last final result is all true, then it's a tautology. Your last final result is all false, then it's a self-contradiction. You don't look at the whole truth table as a whole because your truth table is the same. Your P is the same, true, true, false, false. Your Q is true, false, true, false. So in order to be a tautology, it's got to be the last item, the last column, okay? That's your answer, and that's how you determine if it's a tautology or a contradiction. Is that clear? Now, if you take a look at this thing here, same thing go. For me, the only reason why I move my P over here, again, it's the same P that I have in the beginning. True, true, false, false. I just take the P and I move it over there. The reason why I do that is because of this conditional statement because of this single error. This single error, like I mentioned, this is the one and only time the order matters. And what do I'm looking for? I'm looking for the first item, which is P or Q, which is this item. And the second item, that's why I move the P on the right. Whatever on the right, for me, to make my eye a little bit easier, for me, I move the right item to the right. Because now, all I need to do is need to take this item and I look from left to right. I don't have to go backward and look from right to left. And if you remember the criteria that I mentioned, this is the one and only time for the error to be false. It's the first thing is true and the second thing is false. This is the one and only time that the conditional statement is false. Is the first item is true and the second item is false. Everywhere else, if it does not follow this pattern, if it's not follow this criteria, the first T, error, the second F, then it will be true. If it's follow this criteria, it will be false. So that is why this is a false item here in the third row. So if you look at this item, if you block it in, which is your final product, in order to determine if it's a tautology, self-contradiction, or neither, we just look at the final product. So do you see that the final product here, we don't have all true, we don't have all false. And if we have a mixture, then we say that it's neither a tautology, nor a self-contradiction. Again, it has to be all true, it has to be all false, or it will be neither. You cannot have some and not other. It's got to be all or nothing, okay? All true, tautology. All false, contradiction, and mixture will be neither, okay? So a question here in terms of tautology versus contradiction versus neither. Any question? Question with the criteria of the and, the criteria of the or, and criteria of a conditional statement. The only thing that we're missing on this slide is the if and only if, right? And if and only if double error, okay? If you don't have a question, let's take a look at this item here. So recall on last time, we told you that two statements, in order for two statements to be logically equivalent, the truth table have to be exactly the same, right? At the last item, at the final product, they have to be exactly the same, okay? So how do we find this item, which is the same way we've been doing, in the sense that we need to construct the truth table? So example 2, they ask you construct the truth table for this item and verify if this is a equivalent, okay? So how do we construct the truth table for A? Well, same goal, right? If on Alex, they give you this item PQ, and by now you should be familiar with PQ. P is true, true, false, false. Q is true, false, true, false. And good thing for you guys, with the setting that we have, you don't really need to remember the starter kit, right? But you need to remember the conditional statement, right? So like I mentioned to you guys, please do not distributive anything in, right? We don't distributive anything in. If there's a parenthesis, we want to work with the parenthesis first, and then we just, if it's a negation, we just take the opposite. So reminder, the if and then statement, the only time the if and then statement is false is the first thing is true and the second thing is false. If it's not the first thing is true and the second thing is false, the conditional statement will be true. The only pattern, the only criteria is the first one is T and the second one is F. And reminder, you have to look at the first thing first, which is we need to look at the P first. We need to look at the second thing second, which is the Q. So T, error, Q, this is the first or the only time that is false. Now, we're done with the parenthesis. Now, what do we need to do? Well, we need to do the negation because they did not ask us P imply Q. They ask us the negation of P imply Q. So what is the negation? How do we do the negation? The negation is easy. How easy? All we need to do is we look at the column, which is this column we have P arrow Q, that's what in the parenthesis. We look at this column and we ask ourselves, give me the opposite. So whatever this column true, the negation will be false. False, the negation will be true, and vice versa. So this is my ending. This is my final product. Do you agree that they asked me to find the negation of P imply Q, the negation of P arrow Q? I give to them the negation of P arrow Q. False, true, false, true. Anything else, I don't care. They asked me this item, and that's what Alex does, right? Alex just asks you the final answer. Whatever middle, whatever your step to lead to your final answer, they say this does not grade it. Okay, so that's why I ask you guys to do it on your piece of paper, and then type the final answer on Alex. Okay, because on Alex you have to know how many columns you need to add. And then if you add too much or too little, you might be confused. So just do on your piece of paper. But anyway, A, we are done. Question of A, how we find the negation of the conditional statement here. And B, if we do B, do you agree that PQ is our starter kit? We know that we need to do the AND statement, but before we can do the AND statement, we know that we're missing the negation of Q. Negation of Q, as always, will be the opposite of Q, which is false, true, false, true. Now we have the two items we needed. Like I say, we only compare two items at most. We don't compare more than two items. We don't look at the whole truth table as a whole. Our goal is we need to get to this item. We need to have a column that contains this item. And to contain this item, we need to get there, which is this is how we got there, right? So what is this item? This is the AND statement. The AND statement or the conjunction, and the AND statement or conjunction tell you that as long as, or for me, as long as there's a false, the result is false. So the first line, I see one false, the result is false. The second line, I don't see any false, so that's true. The third line, I see a false, so the result is false. The fourth line, I see a false, so it's false. So in this case, everybody see that my final product, like I say, we don't look at we don't look at the item as a whole. They asked me to come up with a truth table for this. I got it. The truth table for this item is false, true, false, true. Okay. So to go back to our definition for equivalent, to go back to our item for logically equivalent, reminder that if you construct your truth table, and if your truth table match at the final product, everybody see that the final product here, they are exactly matched from line to line. Exactly matched from line to line or row to row, right? The first row, the second row, the third row, the fourth row, exactly matched. And then we say that these two items are equivalent, logically equivalent. Or in another word, we say that to negate the conditional statement, to negate, if you remember last time, the De Morgan law, if you want to distributive this thing in, you can, but there's no longer a conditional statement. To negate a conditional statement, you need to convert the conditional statement to become an AND statement or a conjunction. Okay, so that's what we have here because they are equivalent. The negation of a conditional statement is the AND statement. Okay, so why do I mention that? Because this is well, first of all, question here, how the two items are equivalent. And basically, this is the negation of a conditional statement. And instead of saying the negation of a conditional statement, we say that P and not Q because they are the same. They are logically the same. So before we move to the next item, question with your truth table here. question of how to construct the truth table, and what is the criteria for each statement. The and statement, the or statement, the if and then statement, which is a conditional statement, and the biconditional statement, which is the if and only if. So question here. All right. If you don't have question, let's move away from the, well, let's do one more. I think I have one more, I forgot. Let's do, well, now so this is what we mentioned last time. This two item here, this two item that I mentioned, if you want to negate this item here, reminder to negate the and statement, you have to change it to become an or statement and negate each of them. We mentioned this last time in terms of the Morgan law. If you negate the and statement, it's basically the disjunction of each individual negation. And similarly, if we negate the or statement, you have to convert to the and statement, which is again the conjunction of each individual negation. And we just verify this. If you want to negate a conditional statement, you have to convert to an and statement. Basically, this is what I tell my students is the negation of a conditional statement is kept the first one and negate the second one. The negation of a conditional statement is kept the first one and negate the second one. Okay, so this is your original statement. This thing here tells you that this is your original statement. You have an and statement, you have an or statement, you have a conditional statement. If you want to negate them, instead of negate them like this, it is not true, or is it false, or it is not true that this is the case. Instead of writing like this, we say that they are equivalent, so we write it like this. Okay, that's the idea of this chart here. So before we move to the statement, the definition, not the definition, if you look at the title for 3.3 is the different type of statement. We haven't mentioned any type of statement yet. We just mentioned that if we want to negate, this is the equivalent negation symbolic, okay? So let's take a look at this problem before we move away from the truth table for a bit. So they ask you to verify the two statements are equivalent. Remember, in order to be equivalent, the final product have to be exactly the same. And hopefully by now you know that the truth table for the if and then statement is the only time that is false is the first thing is true and the second one is false. This is the same as before, true, false, true, true. In order to be equivalent, this item have to be true, false, true, true. So if we were to do this, do you agree that what am I missing? I'm missing the negation of P. And negation of P will be false, false, true, true. And now I'm looking, what are the two columns I'm looking at? Like I mentioned to you guys, reminder, I keep on mentioning this, but for any connector, this is your connector here. You only look at two columns at maximum. Okay, whatever the connector is, you only look at two columns. You look at the negation of P and you look at Q. So what is the connector? My connector is the or statement. This is the disjunction, the or statement. And because it's the or statement, for me, in order to be true, the or statement, in order to be true, as long as one of them is true. Doesn't matter which one, as long as one of them is true, the result is true. I don't see a true here, so that's false. I see a true here, I see a true here, so the result is true. And as you can see clearly, hopefully, clearly the end product of this item and the end product of this item are exactly the same. And if they are exactly the same, we say that these two items are equivalent. Everybody see that? So question with, first of all, question with the truth table. How does these two items are equivalent? Or question with the criteria. So let's step away from the truth table a bit, right? Let's step away from the truth table a little bit. We'll come back to the truth table at the end of class, but let's take a look at the variation of your conditional statement, or let's take a look at the type of statement. So I compile everything together. I compile this item that you have everything together. Most of the, if you did your Alex, you probably run across this item already, which is they give you a conditional statement. They give you a conditional statement and they ask you to find the following item. So there are three variations of a conditional statement. There's a converse, there's an inverse, and there's a contrapositive. Okay, so the easiest for me, in order to know how to translate to English, you have to know your symbolic. Okay, so how do we come up, how do we find the converse? To find the converse, this is what you do, or this is what I tell my student to do, is the converse is basically tell you to switch the order. If you look at this item here, if you look at this item, P imply Q. If P, then Q. So imagine that this is your one, right? This is one. This is one. And this is your second statement. This is your two item. So again, this is item one, and this is your item two. So to find the converse, all you do is switch their position. You take the two, you put in front, and you took the P, you put in the back. This is your converse. Swap their position. Okay. And now, what about the inverse? Well, the inverse, all you do is you kept the position the same. P imply Q. You kept the position the same. The only thing you need to do is you need to negate both of them. You need to negate the second one, and you need to negate the first one and the second one. So it's the same position, but you negate both of them. Negation of P imply the negation of Q. And the third item we have is the contrapositive. The contrapositive is basically you swap them around, you switch their position, and negate them. The negation of Q imply the negation of P. And again, I will connect all this together. Right now you say, wait a minute, what all this symbolic? Because it's easier to remember the symbolic. Because the English statement, as you will see, your English statement will change, but your symbolic will never change. Your symbolic will never ever change. You have only one symbolic. Your English statement, as you can see, there are variations. Okay, so the easiest way to remember is they will give you this statement. They will give you some statement. Your original statement will be this item, P arrow Q. To find the converse, swap the position. The P and the Q swap the position. To do the inverse, kept the same position, but negate both of them. The contrapositive is basically the swap of the inverse, or basically you take the converse of the inverse, right? You switch the position and you negate them. And now the other two items that we have. The other two items that we have is this. We verified this earlier, that if we have this statement, we can write this item in terms of the original, not original, but equivalent statement. So if we have a statement and they ask you to write the equivalent, how can it be equivalent? This is equivalent. We proved it before. Prior to this slide, we construct the truth table, and the truth table come out to be exactly the same, and that's why they are equivalent. And for me, this is how I would say it so that I remember it. This is how I say it is I negate the first one or kept the second. Again, You negate the first, there's no longer the arrow, there's no longer if and then. You negate the first one, change it to the or statement, kept the second one. Negate the first or kept the second. That will be your equivalent. And lastly, your negation. Your negation is the and statement. We did this earlier. The negation of the conditional statement is the and statement, which is you kept the first one and you negate the second one. So, you know, that's a little bit, it's take a little bit time to look at this, but basically, again, for the equivalent, you negate the first or kept the second. For the negation, you kept the first and negate the second. Those are the two items. Is a little bit off in the sense of the material. But this is what we do, or in the sense that you need to remember this symbolic in order for you to construct what comes next, right? What comes next is this, ladies and gentlemen. Oh, before we do that, I want to point out, we did not verify this. We did not verify this, but the original statement and the contrapositive, the original statement and the contrapositive, they are equivalent, okay? The original statement and the contrapositive, they are equivalent. If you do the truth table for both of them, they come out to be exactly the same. So basically there are three items here that are equivalent. So this three items is basically is equivalent. If you do the truth table, they all come out to be the same. The other thing is the converse and the inverse. The converse and the inverse, they are equivalent, okay? If you do the truth table for the converse and you do the truth table for the inverse, they will come out to exactly the same, okay? The original statement and converse, is not equivalent, is not negation or anything, it's neither, okay? And the original statement and inverse, they are nothing, it's neither. Converse, inverse, they are equivalent. Negation, not negation, contrapositive and the original statement are equivalent, okay? But let's take a look at what comes before that, or why do I mention the symbolic. So this is your typical item that we have. Is basically they give you this statement. So example 3, they say given a conditional statement, form the converse, form the inverse, form the contrapositive, come up with a equivalent statement and negate this conditional statement. So basically they want you to take this inlet statement. Everybody see the conditional statement they give you is if the weather is nice, then I will go to the beach. So this is the conditional statement. They ask you to come up with the converse, inverse, contrapositive, equivalent, and negation, or negate this. And they want them, if you did the homework already, they want them in English, right? They don't want them in symbolic. But hopefully symbolic help you, right? Let's say that, you know, this is our symbolic, and let's take a look at this thing here, and hopefully if you look at this way, it's a little bit, hopefully a little bit easier. So everybody see the first statement is the weather is nice. Don't worry about the if and then. This is what we have is, the first statement I have is the weather is nice. Again, how can this be a statement? If it's true, if the weather is nice, it's true. If it's not nice, it's false, right? So for now, just disregard the if and disregard the and. So like, again, we have the first statement, number 1, the weather is nice. Number 2, I will go to the beach. Again, if I go to the beach, it's true. If I don't go to the beach, it's false. So that's your statement. We compound them, we combine them with the if and then. If the weather is true, then I will go to the beach. So everybody see that my statement is that here. If the weather is nice, then I will go to the beach. So how do you come up with the converse? Like I mentioned to you guys, this is all you guys need to do is the if and then stay the same. The if and then never change. The if and then just make it easy, keep if and then as it is. Wherever the if and then, keep the if and then. Because If you look at the converse here, the converse is the same if and then statement. It's the same notation. What is different? The only thing different is they tell you take the back item, take the second statement, put it in the front, and take the front statement, put in the back. We swap their places, meaning if I'm going to the beach, or if I go to the beach, then the weather is nice. So this is what the converse is. Your conditional statement is if the weather is nice, then I will go to the beach. Your converse is if I go to the beach. And again, the verb tense doesn't matter. The verb tense, I will, mean in future, and I'm going or I go is the same. So the verb tense doesn't matter. Just don't change beach to bar or casino or something, right? We're keeping the same subject. So if I go to the beach, then the weather is nice, right? So the if and then stay the same, okay? Your converse, once again, your converse is you switch their position. What about your inverse? Same thing go. Same thing go, your inverse. If you can see your inverse, we still have the if and then statement, right? What does the inverse that I mentioned earlier? We kept the same location. Whatever your original statement is the same, but the only thing is we need to negate both of them. So let's clear this out. Let's take a look at the inverse. I will have the other slide back. So if you did not copy it, it's okay. Inverse, this is what we have is we kept everything the same. The if and then stay the same. The weather nice same. We'll go to be same. The only thing is we negate them. How do we negate them? Reminder, if they don't have the word not, we insert it in, which is if the weather is not nice, then I will not go to the beach. Again, the negation is easy because if your item do not have the word not, we insert them in. If your item have the word not, we take them out. But see that. My original statement do not have the word not, so I put them in. My original do not have the word not, so I put them in. So again, if the weather is not nice, the negation of P, then I will not go to the beach, negation of Q. So that's your inverse. Your inverse is kept everything the same location, but negate both of them. Negate the first and negate the second one, okay? Converse, swap the position. Inverse, kept the same, but negate both of them. The contrapositive, once again, the contrapositive is the if and then statement once again. Your contrapositive is the same if and then statement, but what do? We need to, the if and then statement is the same, we need to switch them around and negate them. We need to switch them around, which is now, if I do not go to the beach, then the weather is not nice. We swap the two statements and we negate them, okay? Like I say, I will not go and I do not go is the same. The verb tense doesn't matter. If you want to say I don't, it's fine. But again, I do not go to the beach, then the weather, if I do not go to the beach, then the weather is not nice. Like I say, keep the if and then the same location. It's just you swap your statement. So those are your three items here. Your converse, you swap the position. Your inverse, you kept the same, but you negate both of them. And your contrapositive is you do both. You swap them and you negate them. So question here in terms of the converse, inverse, contrapositive. And now, if you look at this item here, no longer do we have an if and then. How can we come up with an equivalent, another equivalent item? We no longer have an if and then statement, right? This equivalent statement tells us that it's an or statement. And this is what I told you guys. We no longer have an if and then statement. We need to negate the first one. What is my first item? My first item is the weather is nice. How do I negate them? The negation is the weather is not nice. Or I will go to the beach. So this is why I told you guys is negate the first one or kept the second one. That is the equivalent negation of the first or kept the second. Again, the if and then is not the part of the statement. It's the compound statement. It's combined two items together, right? The or is the new compound here. We negate the first one or kept the second. And lastly, if you look at the symbolic, this is the and statement. The negation, to come up with the negation, is basically tell you to kept the first one and negate the second. We kept the first one and negate the second. So if I kept the first one, it say the weather is nice. I kept it, the weather is nice. And there, this is my and statement, the upside down V. And negate the second, which is I will not go to the beach. Okay. So this is the idea, or this is the obstacle that you have or that you will deal with in the sense of this particular item. In the sense of this particular item, this is your obstacle. How can you take the original conditional statement and find the converse, find the inverse, find the contrapositive, find the negation, and find the equivalent? Okay. So first of all, before we continue, one more item, or I have two more. Before we continue, let me ask you guys a question here. Any question with the converse, inverse, contrapositive, equivalent, and negation or negate? All right. If you don't have a question, let's take a practice for another one. All right. Let's practice another one. Same idea. If you look at this item, let me clear this out to make it a little bit nicer. If you look at this item here, if I have a flat tire, then I'm not going to work. So again, as I mentioned to you guys, the statement is the same. Not the statement the same. The notation, the symbolic is the same, right? The symbolic is P arrow Q. The symbolic is the same. The only thing different is your statement. Now, instead of tell you the weather is nice and you go to the beach, they tell you that if you have, or if I have a flat tire, then I'm going to stay home. I'm not going to work, right? So as you can see, the statement here are different, because last time, weather night, I go to the beach. This one here, flat tire, not going to work, right? So doesn't matter what the statement is. The symbolic is the same, and that's why I want to emphasize that it's easier to remember the symbolic, and then you take the symbolic and you convert to your English statement. Because on Alex, if you already encountered this, if you did this on your homework, you already encountered that you have to write in English form and not symbolic form. So have this as a reminder, right? But again, it's easy to remember. If you repeat this 10 times, if not 100 times, you should remember it, right? What is the converse? Remember the converse, the if and then stay the same. But what do? We say we switch their position. So what is the position? The position will be, if I'm not going to work, then I have a flat tire. And as you can see, this statement might be true. If I have a flat tire, I might not go to work. But this statement might not be true, right? I can be sick. I can be something else, right? It's not necessary that I have a flat tire, right? So again, the converse, to go back, the converse is basically you swap the position. You swap the two statements. You take the back statement, put in front, the front statement, put it back. The if and then stay the same. Similarly, the inverse, what do we do? Well, we kept everything the same. We kept everything the same, but we negate them. What do I mean? We negate them, meaning if I have the flat tire, the negation will be if I do not have a flat tire, then I will go to work. Like I mentioned, if your statement do not have the word not, we put them in. If your statement do not have the word not, we put them in. If your statement have the word not, we take them out. And again, I'm going to work is fine. I will go to work is fine. Like I mentioned, if we don't have, we took out the word not, and that's how you negate them, right? If they don't have the word not, you insert them in. If they have the word not, you take them out. That's all the negation is. The squiggly line tell you to do that, okay? So the inverse is if I do not have a flat tire, then I will not go to work. And what about the contrapositive? If you can do the inverse, just thinking you flip the inverse, right? Whatever your inverse is, you switch the order, meaning if I am going to work, then I do not have a flat tire, okay? You switch them and you negate them. Or in a sense, you take the inverse and then you swap them around. Either way, however you see it, you just swap them and you negate both of them, move the back end to the front end and the front end to the back end. So first of all, question with the converse, inverse, contrapositive. Now, how do we negate this? Not negate, how do we write another equivalent? And reminder, the conditional statement, the original statement, and the contrapositive, they are equivalent too. Okay, the contrapositive is equivalent. This one here, how can we write another equivalent statement? Alex asked you and challenged you, which is, if you remember, we negate the first one. There's no longer if and then. This is the or statement and this is the and statement. We negate the first one, which is I do not have a flat tire, or I am not going to work. We negate the first one or kept the second one. So the second one stay the same. We negate the first one and insert the or statement in. And vice versa, how do we negate this? To negate this, we kept the first one. Whatever the first one is, we kept the same. We change to an and statement, and then we negate the second one. I'm not going to work. You negate them to be I am going to work. So I have a flat tire and I'm going to work. As you can see, it would be very hard if you have a flat tire and you're going to work, okay? So again, without changing the flat tire. So first of all, this is the idea. This is our objective. This is our objective in the sense that if you do the homework or if you do Alex over the weekend, you will encounter, I guarantee you, you will encounter the converse, inverse, contrapositive. And the other one is you will encounter equivalent negation item. So question here, question on how to construct this in English. So if you remember, if you remember this symbolic, it will help you very much, okay? The notation, because the symbolic is always the same, the only thing is you just convert back to English. So let me skip this one here. Let me skip this one here. We go back if we have time, but again, you can write this thing down. You can write this thing down and see if you can do the converse, the inverse, the contrapositive, and the negation. Again, if class is not canceled, then you have a test. So looking at this thing here, like I mentioned, the symbolic doesn't change. The statement changed. The first one, if you remember the first one, if the weather is nice, I will go to the beach, meaning both of them are positive. The second statement is if I have a flat tire, then I will not go to work. The first thing is positive, and the second one is negative, right? Not going to work. And now they're changing it. If the class is not canceled, meaning the first thing is negative, then you have a test. The second one is positive, right? So again, they can change it, and they can change whatever statement they want to. Right? They can change, and if you did the homework, I think like if the zoo have zebra and the zoo does not have a lion or something like that, right? No matter what statement they give you, ask yourself what is the first statement and what is the second statement, right? The first statement is class is not canceled. The second statement is you have a test, right? So again, just ask yourself what is the statement, and all you do is the converse, you swap them around. The inverse is you kept the same, but you negate both of them. The contrapositive is you swap them and negate them. Another equivalent statement is you negate the first one or kept the second one. And the negation is you kept the first one and negate the second, or but negate the second, okay? So let me skip this. I have the answer, but you can try. You can try that at home. Let me go to this thing before I run out of time. Let's take a look at this item here. So let's go back and practice those converse, inverse, contrapositive, and negation. But let's go back to this item here. This item, they want to challenge you, and this is the most challenging part of truth table that I think, right? Doing truth table is fine. Doing truth table, if they ask you to construct, is fine. But now, what if they give you a bunch of truth table and they ask you to fill in the missing pieces, right? They only give you this item A, B, C, and they ask you to fill in the missing pieces. And this requires you to understand and know your criteria by heart. Basically, you have to know what the notation is. So looking at this item here, we know that at this column, we are dealing with the negation of C. So that should be easy. At this column, we deal with the operation OR. And at this column here, we do the operation AND. Okay? So first of all, you have to ask yourself this item, right? This is the negation, and this is the OR statement, and this is the AND statement. So make sure you know your notation, right? And make sure that at this column, like I mentioned, we only look at two things at once. So first of all, the negation should be easy, right? The negation of C is basically tell you, looking at C, look at C, we don't care about A, B. Look at C, what does C give you? Give me the opposite. The negation is the opposite. Do you agree that C is true? I can fill in the negation of C, which is negation of C is false. So find the negation is that easy, it's just the opposite, right? And now, how do I find this item here? Well, this item tell me, look at A and B, right? Or in terms of this, A or B. So what is the OR criteria? Reminder, the OR criteria tell me is as long as I see a true, the OR criteria is as long as there's a true, the result is true. The OR criteria, the V, which is the OR criteria tell me is as long as there's a true, the result is true. So I don't care about B, as long as one of them, my A is true, so I have a true statement, okay? So that's my OR statement. So we got this item, right? Ladies and gentlemen, we got the first item. The first item is negation, which is the negation of C. We got it. The second item is the OR statement. We got the OR statement, which is the B or A. And now they ask you, if you have those two, can you find or finish this item, which is the parenthesis A or B, which is right here, and negation of C. So how do we find the AND statement? Well, reminder, the AND statement is the criteria for the AND statement for me, as long as one of them are false, doesn't matter which one, as long as one of them is false, the AND statement tell me that is false, okay? So this is, the reason why I say it's challenge is because you basically have to know the criteria by heart, right? The negation is the opposite. The OR is as long as one of them is true, the result is true. The AND is as long as one of them is false, the result is false. You have to know that by heart for you to kind of dissect each item. and they don't just give you just here, right? They scatter them around. And you know, and this is the one thing is, if you're good at analyzing, and this is what we do, is we ask you to analyze your problem, analyze what they give you. And, you know, if you're good at puzzling, this is your, you know, in your ballpark, right? So before you do anything, this is what you have, right? You have to ask yourself, well, what are we looking for here? Right here, the connector we're looking for is the negation again. And right here, we are looking at the if and then, okay? So looking at this item here, we are looking for the if and then statement, or the conditional statement. This is the negation. So the negation, hopefully, if you look at this thing here, we can do the negation, right? Easy negation. C, if C is false, the